Okay, hello. So I am just going to go over a problem that we didn't get to in class today, which is okay. So you want to make sure you title this Unit 3, 3.21, and we're focusing on solving simple equations. Okay, so we are going to scroll down all the way to the exercise 3 that we didn't get to. So you can go ahead and take the time, pause the video to write this. We're solving for the following equation for x for this one. So I'm going to go ahead and zoom in so we can see this a little bit better. Okay, so always when we are solving for an equation, especially a rational equation, is that we want to take into consideration restricted values, right? So here, I can already eyeball this, that x cannot equal -1, right? So if I substitute -1 right here, I know that will give me 0. And so this will give me an undefined value, or yeah. And so restricted value, and so these are, remember, these are ones that will make it undefined. So then what's interesting though is that this one is an x squared minus 1. And so that becomes the difference of squares. So I know that this will become 2 binomial conjugates, x plus 1 times x minus 1. So even though I already noted that x cannot equal -1 because I have an x plus 1 here, I also have an x minus 1. So another restricted value is also a positive 1. Okay, so now that I've factored my denominator and identified my restricted values, I can go ahead and figure out what is my least common denominator. So I have 2 over x plus 1 equals x minus 3. And then I have x plus 1 times x minus 1. Now, because this is the case, I have to see where is my least common denominator. So I remember when you're working with binomials in the bottom, you're looking, the least common denominator are the ones that have the unique factors. So I have an x plus 1 and x plus 1. So that's going to be part of my least common denominator. I also have an x minus 1. So that's also part of my denominator, or part of my least common denominator. So here, all I have to do for this problem is multiply the bottom times x minus 1 and the top by x minus 1. Okay. Once I do that, I can go ahead and figure out what my x value could be. So I can rewrite this as x minus 1 times 2 equals x minus 3. And it's all over the same common denominator. Okay, now this is the new piece in your notes where once we find, when we're working with equations, and once we find the same denominator, we can go ahead and just rewrite it with the numerator. So I'm just going to focus on the numerator here, which is this piece. Okay, so I can go ahead and write this as, I'm going to go ahead and distribute as well. Okay, so this will become 2x minus 3 equals x minus 3. Okay, so this one requires a little bit more work to find my x value. But using your Algebra 1 skills, we can go ahead and solve this very quickly. So I can subtract x on both sides, and I'll get 1x minus 3 equals -3. Wait, what? Did I do an error? Oh, I did. It's okay. Some of you are all like telling me I did an error. Okay, sorry. So 2 times x gives me 2x. 2 times -2 gives me -2. My mistake. Okay. And then here this becomes a -2. Okay. So sorry about that. And then once we get to this level, we can go ahead and isolate our variable. We can add 2, and we'll get x equals -1. Now, we already said that a restricted value is that x cannot equal -1, but we got -1 as our answer. Well, that's not possible. So what we have to say is that if we get this situation, it is called a no solution. Okay? We don't have an answer because we got x equals -1, but -1 is one of our restricted values, and that can't happen. So therefore, there's no solution. In this case, what has now occurred is something called an extraneous solution. Okay, there's different vocabulary, but right here, this extraneous solution has a specific definition. Okay, so when you have an extraneous solution, it is a solution that is invalid and can occur when we solve for a rational equation. Okay, and there's essentially two ways that you could get an extraneous solution. One way is that it could be the answer that you got was maybe one of the restricted values, so therefore it automatically does not have a solution. Or what's going to happen, which you will see in your homework, is that you do all this work. Then let's just say this was x equals 2, for instance. But what would happen is if you substitute 2 in here, you'll notice that they both won't equal the same. They won't be equivalent. So in that case, it is also no solution. Okay, so the answer that you got was an extraneous solution. So here we can say another option is that after verifying, okay, I'm messing up. Where is it? Okay, so after verifying, if the expressions are not equivalent, then it is also an extraneous solution. Okay, and so that's it. The rest of your homework is going to be this problem set here. So you'll notice that a few of them will not make sense after you substitute or after you verify. So that's going to be that solution that you get is going to be an extraneous solution. So making sure that you understand that. So if you have any questions, just go ahead and email me, or you can bring them to class next time so that way we can walk through that a little bit more. Okay, and that's it. Where is this?